Now we will have Damien Garros, who will talk to us about automation. It's coming up, and then you have it here.
Thank you. Hi, everyone. I feel like I'm in trouble. I realize I do not have the AI slides in there, so I hope you will forgive me. So we're going to talk about, building trust in automation. And I want to say as an intro, it's not, maybe as a show of hands, like how many of you are actually building automation today? I'll say maybe a quarter of the room. And how many are just using automation, not building it? Are you just using it on your day-to-day and someone else is building it for you? I would be very surprised if no one is raising their hand. Well, let's assume that there's still some people. But this presentation, even though it is about automation, I really built it as both for the builders and the consumer of automation. And my goal is to actually try to have some shared languages and understanding of what is important, because at the end of the day, we'll talk about it, but automation is for the users. And I think for too many places, with the people that have been building automation, they kind of lost the importance to actually make it consumable, and that's where this idea of trust comes from. So very quickly about me, my name is Damien Garros. I'm the co-founder and the CEO of OpsMill. We're building a next generation infrastructure management platform. There's a really cool talk, I think, just after me that will show you how that works. And pretty much I've been doing, come from a networking background. I've been doing automation for the last 12 years. I try to put everything I know into this presentation and into InfraHub. So why trust? Why trust is so important. And I mentioned, to me, I've seen so many efforts, project tools over the year that never get adopted. Like people spend a lot of time building them, and then we give them to the operation team, and then they just go around those tools and keep doing what they're doing because they don't want to use them. In my perspective, the big issue is trust. So let's try to visualize that. What if I gave you this black box with a red button on it, and I told you, trust me, just press this button, I will upgrade everything on your network. How many of you are going to do that? Thank you, Eris. Thank you for trusting me. And I think, and many of you will be like, but that's completely stupid. Nobody will build such bugs because, of course, nobody's going to press on that. But I think the truth is many of us have done that. And the truth is, from the user, it looks like a black box. But for the guy who built that, it doesn't look like it. The person or the team who built the tool, they will actually feel that the tool is great because they understand everything inside, they understand how it works. And so they will trust their own tool, but it's just that nobody else will. And that's where a lot of these disconnects come from. And I think what we're losing along the way is that to build trust, we usually focus on making it work, making the playbook work, but we forget that to actually make it usable and trustable by the rest of the team, it has to be predictable, it has to be manageable, transparent, reliable, human-friendly, simple. And that's a lot of work, and that's to take a lot of efforts to do that. If we took another, because I love analogy, if we took, for example, a car, just to represent how it looks like. If you ask me to build a car today and say, hey, Damien, I need a car, and I need it to go from A to B, I will probably give you something like that. I swear it goes to A to B, it doesn't guarantee that it has brake, probably doesn't have door, probably doesn't have mirrors, but it technically works, it does the job, it is working. Now, are you gonna put your family on it? Are you gonna trust that it will actually safely get you from A to B? I assume probably not, and probably what you had in mind initially was probably more something like that, like a real car, not just something that will get you from A to B. And so again, I think it's really where this disconnect between the builders and the users are coming from. So to me, the principle to build trust is really about, we need to understand users need to understand what the tool is going to do. It has to be predictable. They need to be able to configure it, to manage it. They need to have some understanding of what will happen and that there's, of course, no surprises. That's the worst. And somehow needs, of course, to be simple, reliable. Of course, if it keeps failing and there's bugs and it just explodes in the middle of what you're working, of course, no one is going to trust the tool like that. And it needs to be human-friendly. So that's very, bullish. And you could say like, who is this guy to tell us that? And I just want to say that my goal here in the presentation, and we're going to talk about the rest of the presentation on how do you achieve that or how do you get closer to that and what's some of the building blocks. But I think my point is achieving all of that is really, really hard. And I don't pretend that everything I built has that. So actually, quite the opposite. If you look in my garage, there's cars that don't have wheels, don't have engines, don't have, like, every mistakes I made them. And it's really like more me sharing my mistakes. But I think what's important is just try to do one more. Like, try to see how you could improve on one of those dimensions and, keep progressing. And it's a journey. There's no tool that starts from day one with, all the checkbox and every bits of visibility and predictability. But again, so it takes some efforts. It's a journey. And hopefully this presentation will help builders and consumers to actually discuss like, hey, how could we improve this aspect of the tool? So with that, let's look at what are the design principles to build trustworthy automation. Some of them, again, if you're in automation, might sound obvious, and that's good. But I actually found over the years that it's really important to educate on it because there's still a big part of the industry, in my perspective, that doesn't know those really key design principles. So the first one is idempotency. Idempotency is, I usually say, is something that's hard to pronounce. It's actually really easy to understand, but it's really hard to implement. And it's this idea that if you do a task, you can do it many, many times, you will always have the same result. So if we take an example from the networking industry, it's, to me, the best example of idempotency is DHCP. If you don't have DHCP, every time your laptop connects to Wi-Fi, it's going to ask for an IP, you will get a different IP. And soon enough, you will run out of IP, you will not have any IP. But with idempotency, the laptop comes in, asks for an IP, and then you always get the same IP. That's, I think, the basic definition of it. It's like from the client, you just define what you want, and then there's something else that will understand what was the previous state, what is the current state, and what's happening. And the same goes for any form of playbook or scripts or all of that you implement. Now, idempotency, it is a cornerstone of automation. It is extremely important. But as I mentioned, it's actually really, really hard to build. And while some tools like Terraform or Ansible, we'll talk about it, have that kind of built in, if you write your own script, your own Python script, most likely you won't have that out of the box. And just to give you to appreciate the complexity, idempotency is actually all about the state. Like, why DHCP work? It's because there is a server somewhere that is keeping the states of the past request and understand based on your MAC address that you already had an IP, and that means that the client can be stateless and doesn't have to remember anything. And that's what makes it so great. So this idea that we basically move the complexity from the state, from the client to the server. So keep idempotency in mind. The second one is dry run. This idea that we will be able to see what a tool or systems will do without actually doing anything. So if we go back to our black box example, let's say that now I have a green button next to the red button. And if you click on it, it will show you everything that's going to happen, every system that will be touched and modified without actually doing anything. And at the end, it will say, do you like what I'm going to do? Do you want me to actually make those changes? And I bet that now, actually, a lot more of you will be ready to press the green button and potentially then apply the red button. So that's, again, a key principle of automation that is very important. It is kind of supported by most of the tools. Actually, Ansible, I hate that they don't even make that by default, but there's two options in Ansible that are called diff and check. If you use them, they will usually show you exactly what's going to happen without making any change, and then you have the ability to decide if you want to execute on that. That's some of the things that have been built into Terraform from day one, and some of the new tools like Kubernetes, they also have that built in. And now the third principle is this idea of transactional. Transactional is this concept that if we have to make multiple changes, either all of them succeed or all of them fail, but you won't end up being stuck in the middle, which will be, in a lot of cases, really, really bad. So this idea of transactional, I guess I already covered that. All of them succeed or all of them fail. It is also like really hard to implement, but when you have that, it really helps with the implementation of automation. So those three design principles, idempotency, dry run, transactional, they're really fundamental to help achieve the earlier principle that we discussed. And what's important to understand is, even though we talk about them independently, and they each, you could read about them, they actually have a virtual circle. Like, it is so much easier to actually define something as idempotent, to do a dry run when you have something that is idempotent, because usually you will be able to have a diff. And then if you have a dry transactional, also usually that kind of goes together. So as soon as you start in this journey and you start implementing some of them, that makes a big difference in the implementation. Now, if we go a little lower, let's look at the tools and the technology that actually makes it possible to implement those principles. And I have three that I think are super important to discuss. The first one is this concept of declarative versus imperative, version control and testing. So let's talk about that. This one is probably one of the most important, and that is so often misunderstood. Or this concept of imperative is where we focus on the actions, and the declarative focus on what we want to achieve, more of the outcome. So to give you an example, like an imperative approach is, if I want to change the VLAN, I go on a CLI, I go in config mode, I do the change, configuring the VLAN, and then I exit. That's the imperative approach. Where the declarative approach is going to focus on what is the end state that I need, and then you just define that I want VLAN 10 on a specific interface, and the tool will figure out how do I get there. What we see is that most people that start into the automation journey, they usually start on the imperative approach, because that's what's the closest to what we do as human. Just a suite of steps that we execute one after another, and exactly like we mimic the human behaviors. But actually, the most powerful automation tool that I've seen, they really go more into this declarative approach, and it's this change of mindset that is super important. If we look at the tool that you have out there, just to give you some perspective, all the new tools, Terraform, Kubernetes, or even config files or NetLab, I should put NetLab in there, has this declarative approach where you define everything in config and you apply, and then that's what does the job. Where the imperative will be more anything that mimic the CLIs, like NetMiko or CLI, or any form of CI pipeline, for example, with Jenkins. Now, personally, I found that Ansible is interesting because Ansible can do both. And I've seen a lot of people getting mad at Ansible or criticizing Ansible for its complexity. In my experience, it usually means you're using it the wrong way. If you use it in an imperative way, it's going to be really complex, because imperative is complex, not because Ansible is complex. And if you actually use it in a more declarative way, the way NetLab is using it, just build the config and apply the config, it's actually much, much better. To visualize that a bit more, an imperative approach is this idea that every workflow will need to be composed of many, many steps and will need to touch a lot of different systems. And so as you have more and more workflow, you see that you start to build this spaghetti of code that makes it really hard to develop, really hard to maintain, and all of that. If we put a curve here, so the green line represents the complexity based on how many steps you have in your imperative workflow. The more steps you had in your workflow, the more complex it will be, the harder it will be to develop. And you can see that the red line is more like the trust level, like the probability that people are going to want to actually use that workflow. And in my perspective, it's probably even optimistic here. Like, if you go more than 5 or 10 steps, it's going to be a nightmare to develop, a nightmare to maintain. So the other approach is to go more with the declarative methods, where what happens is the declarative is usually you have a source of truth or a system in the middle where you actually define what it needs to look like. And then you'll have smaller workflow or agents that will just apply those states or the definitions to part of the infrastructure. And so you kind of put an abstraction layer on top of it. And that's, again, makes a big difference on how you develop and the trust and all of that. If we bring back this design to the design principle earlier, we see that when we do imperative, it is actually really hard to do something that is idempotent. Because if we need to consider all the steps along the way and understand what was applied before, it's hard to do dry run, and it's almost impossible to do transactional. Where when we actually have the declarative approach, it naturally aligns with some of the principles we talked about earlier. And declarative is kind of synonymous for idempotent. And usually if you use it with version control that we're going to talk about in a while, it's actually very easy to apply dry run and transaction. So speaking about version control, this idea that version control, it lets you prepare your changes in isolation, validate safely, have them being reviewed, and then integrate them into the main branch. So many of you might have heard about Git. That's probably how most of us got introduced into version control. I think what's very exciting nowadays is that version control is coming to other tools in our tool sets. So for example, multiple tools, including us with InfraHub, now we're bringing version control to the database, to more like enterprise tools. And more tools are following these patterns that we want to be able to make changes in isolation, being able to have review, and be able to have CI/CD pipeline, not just on Git. And that, again, makes it's a complete game changer in terms of how we actually collaborate. Back to those principles, because version control, by definition, it has this concept of dry run, meaning because we create in isolation, we usually have a diff. It's very easy to review what's going to change. By definition, it's transactional. And usually because we are applying things in steps and we have this, the way it works, actually, version control is usually it also work very well in an idempotent way. So there's really great, it's very complementary with the other solution. And the last one that could probably go on a full talk, but I'm very briefly going to talk about it, is this concept of testing. Testing is extremely important, of course, to make something that is reliable. But what I've seen over the years, it's kind of to be more of an afterthought for a lot of people that are building a solution, and especially as I've seen a lot of people that are like, if we're just integrating tools and not building them, it feels sometimes that achieving proper testing is not going to be possible. And I'm not talking about the labs that NetLab is doing in terms of testing. I'm talking about testing your software stack, your tool stack, all the tools that you have that are actually generating, pushing changes and all of that. So testing is really has to be a design choice. And in my experience, there's two cases. Like it's really something actually that takes a lot of practice. But if you have no tests, you're going to be in trouble. But if you have, I've seen also young engineers that heard someone on a talk say you have to do 100% testing because that's the way to go. And then from day one, they put way too many tests in a way that paralyzed completely the project. So there's really a sweet spot in there. And it's very important to find it properly. And we'll talk about it. It's also to make sure that the entire stack and the tools that you select are actually going to help you get there. So just in terms of terminology again, this goal is not of this presentation to be a full presentation on testing, but there's usually this concept of unit test, integration test, and end-to-end test. I will say the sweet spots in a lot of cases is probably in the integration test. There's a lot of, again, I wish I should start working on a presentation just about that because there's a lot of things to do. I've seen so many people like doing over and over the same manual test, spending hours and hours just doing that. And it's like, oh no, I don't want to do tests, it's too complex. But then they just realize that they spend hours and hours building those tests manually. I think one of the signals is that if you feel like it's too complex to implement some testing, it is probably because your solution, your architecture was not properly designed. In my experience, that's usually really big, like signals, like we call that a code smell in software developments. That maybe you need to rethink how things are defined. And we go back to this imperative versus declarative workflow. If you have a imperative workflow with 15 steps, it's probably going to be really hard to test. Maybe it's a good sign that you need to redesign architecture to have more of a declarative approach to be able to, and that will naturally makes it easier to test. And just to finish, I think I have 2 more minutes. Just a matter of time, actually, I had a few more tips and all to get started, but I just wanted to keep those 2. In my experience, as we're building, one of the issue that I've seen in our industry is that we tend to reinvent the wheel all the time. I've done it so many times, and so my advice will be like integrate what you can and build what you must. Like it is so hard to actually build the entire stack. There's so many complexity in there, especially if you want to focus on visibility and predictability and building trust in that. So really focus on what you cannot integrate, what doesn't exist out there, and work with the community on it. And then the second one is, as we actually select tools, just make sure that we check for, the tool that I select is going to be easy to integrate in my testing? Does it provide enough visibility? Does it support declarative behaviors? Like, let's just focus on how it works on the happy path, but also consider all those other aspects, because I think they're very important and often like second thoughts to this decision process. With that, thank you. If you have any question, I don't know if we have time. Maybe a few questions. Otherwise, yeah, happy to chat at the break.
No one? Okay. Sorry, give me the mic. Say your name and ask the question.
Hello, I'm Benjamin from PicTet. You mentioned transactional, and you mentioned that it was hard to implement. I agree. How would you recommend to do it like with network devices? Because in a database, it's built in. There is transaction. It's easy. In devices on which we need just to pass API calls or run CLI commands, how do you implement?
I will refer to my last slide. You need to pick the right tools.
Okay.
I mean, if you start with a network device I think the answer to your question is you need to go in declarative approach to your configuration. That's what a lot of people have been doing. Build the entire config, you apply the entire config. It's or the snippet of config at once. That makes it easier to do that. There's also devices like Junos now. Junos has done that for 10 years, like the commit, that by definition makes it transactional. I think Arista has it now. Some of the Cisco have it now. So I think it's back to that. Like I was more thinking about the software stack, but it goes all the way to the network device. You got to build the right tools. You got to, if you want to be able to build the lab that Ivan mentioned earlier, you need to pick a vendor that has a virtual device and makes it easy for you to use. Like it has to start at the beginning and start with the network device, but it's true all the way to any tools that you want to select in your stack.
Okay. Thanks.
Questions?
Vincent from Free. You didn't talk about the source of truth on data validation. Do you have tips on that?
I was trying not to talk about source of truth, and there's more of a generic tool. But I think again, version control is coming to source of truth, like all the different solutions, whether it's Netbox, Notebot, InfraHub. All solutions are working on it now. That I think are, is the path to have proper data validation, so that we'll be able to make change in the branch and actually have some form of CI pipeline and validation that will be able to kick in before merging that in. So I think that's that'll be my answer to that.
Okay, thank you very much, Damien, and sorry for the mix-up.
No worries.